Hello students, today I will discuss values of trigonometric functions at sum or differences of angles. Let there be two angles A and B and you want to find the trigonometric function sin A plus B. So first formula sin A plus B. Trigonometric function sin at sum A plus B is equal to sin A cos B plus cos A sin B. Second, sin of A minus B is equal to sin A cos B minus cos A sin B. In sine functions at sum or difference of the angle, you have the same sign here. Plus sign, minus is here, then you have minus here. Third, cos of A plus B is equal to cos A cos B minus sin A sin B. In sine cos function, we have the opposite sign. If plus is here, then we have minus here. Fourth, cos of A minus B is equal to cos A cos B plus sin A sin B. Opposite sign. Now fifth, tan of A plus B. Tan of A plus B, this formula can be derived by using the formula of sin and cos. So tan A plus B is equal to sin A plus B upon cos A plus B. And this is equal to sin A cos B plus cos A sin B upon cos A plus B is equal to cos A cos B minus sin A sin B. Now if we divide the numerator and denominator by cos A cos B, the numerator and denominator is converted into tan. So dividing numerator and denominator by cos A cos B, if we dividing numerator and denominator by cos A cos B. So if we divide numerator and denominator by cos A cos B, then this is equal to sin A cos B plus cos A sin B upon cos A cos B upon, in the denominator, cos A cos B minus sin A sin B, cos A cos B minus sin A sin B divided by cos A cos B. Now if we separate the terms, then sin A cos B divided by cos A cos B cancelled, sin A upon cos A, which gives equal to tan A plus cos A sin B divided by cos A cos A cancelled, sin B upon cos B plus tan B, and in the denominator cos A cos B divided by cos A cos B is 1 minus sin A sin B divided by cos A cos B, sin A upon cos A is tan A, and sin B upon cos B is equal to tan B. So the formula is now for tan of A plus B is equal to tan A plus tan B upon 1 minus tan A into tan B. Similarly, we can derive the formula for tan A minus B, which is tan of A minus B is equal to tan A minus tan B. In the numerator, we are having the same sign which we have here. Here the sign is minus, so we have minus here. And in the denominator, we have plus. 1 plus tan A tan B. In the same way, we can derive the formula for cot A plus B. For cot A plus B, the formula is cot of A plus B is equal to, formula for cot A plus B can be derived from here. If I write 1 upon cot B here, 1 upon cot A here, 1 upon cot B, then 1 upon cot A, 1 upon cot B, and then I take the reciprocal to get cot of A plus B. Then the formula is cot A cot B minus 1 upon cot A plus cot B and for cot A minus B, cot of A minus B, this is equal to cot A cot B plus 1 upon cot B minus cot A. This formula can be derived from here. Take the reciprocal, write 1 upon cot A minus B here, then 1 upon cot A here, 1 upon cot B, 1 upon cot A, 1 upon cot B, and then take the LCM, you will get this formula. Though questions can be solved using these formulas, tan A minus B and tan A plus B. So these were some of the formulas in which we have calculated the sum or difference of the trigonometric functions sine, cos, tan and cot. Next, formula number 9. Sine square A minus sine square B, or sine A plus B into sine A minus B. Sine A plus B into sine A minus B is equal to sine square A minus sine square B. Tenth formula, cos A plus B into cos of A minus B is equal to cos square A minus sine square B. These formulas can be derived using the formula of sine A plus B and sine A minus B. So I will derive this formula, sine A plus B into sine A minus B is equal to sine square A minus sine square B. So how you will derive this? First write the formula for sine A plus B, which is sine A cos B plus cos A sine B. Now write the formula for difference, that is sine of A minus B into sine A cos B minus cos A sine B. Now this expression is in the form of A plus B and into A minus B. So using the formula A plus B into A minus B is equal to A square minus B square. So if we use that formula, we can write this is equal to sine A cos B its square minus cos A sine B its square. which is equal to sine square A cos square B. As you know, A into B square is equal to A square into B square minus cos square A into sine square B. Now sine square A into, right, you can write cos square B as 1 minus sine square B minus cos square A you can write as 1 minus sine square A into sine square B. If you simplify it further, then sine square A multiplied with 1 is sine square A minus sine square A into sine square B is minus sine square A sine square B minus sine square B, and because of this minus sign, minus and minus is plus, plus sine square A into sine square B. This sine square A sine square B and sine square A sine square B get cancelled. So ultimately, finally we get sine square A minus sine square B. In the same way, you can derive the formula for cos A plus B into cos A minus B. First you have to write the formula for cos A plus B, then cos A minus B, same concept, and then in the last you will use these identities to simplify it. So second formula is for you to verify it. Now I will discuss some of the problems of values of trigonometric functions at sum or differences. How will you use these formulas in solving the problems? So first question is, if sine A is equal to 12 upon 13 and sine B is equal to 4 upon 5, angle A is greater than pi by 2 less than pi, and angle B is greater than 0 less than pi by 2, means this angle A lies in the second quadrant and angle B lies in the first quadrant. This angle lies in the second quadrant and this angle lies in the first quadrant. Then evaluate sine A plus B and cos A plus B. So in this question, what you need to do? First you will write the formulas of sine A plus B and cos A plus B. So first let us solve for sine A plus B. So sine, first part is sine A plus B is equal to, as you know, I told you in the beginning that sine A plus B is equal to sine A cos B plus cos A sin B. Now already you have the values of sine A and sine B. Sine A is positive because it is in the second quadrant, and sine B is also positive, it is in the first quadrant. Now what you need to do here, you need to calculate the value of cos B and cos A. So how will you evaluate cos A? Cos A, because A is greater than pi by 2 and less than pi, means it lies in the second quadrant, and in the second quadrant cos is negative. Using the ASTC rule, you know, ASTC, in the second quadrant sine and cosec are positive, so cos is negative. So cos A you will consider, though cos A is equal to plus minus under root 1 minus sine square A, but I will consider only because the angle lies in the second quadrant, so I will consider only cos A is equal to negative sign minus root 1 minus sine square. And the value of sine A is given here 12 upon 13. So this is equal to minus under root 1 minus 12 upon 13 square. And 12 upon 13 square, students, you know 12 square is 144 and 13 square is 169. So this is equal to minus under root 1 minus 144 upon 169. On further simplifying this, you can have cos A is equal to minus under root, on taking the LCM, 169 minus 144 upon 169, which is equal to minus under root. 169 minus 144 is 25. 25 upon 169, which is equal to minus 5 upon 13, because square root of 25 is 5 and square root of 169 is equal to 13. So we have got the value of cos A is equal to minus 5 upon 13. Now one more value is required here. Cos A and cos B is also required. So cos B is equal to, and for cos B you will consider only plus sign here, because the angle B lies in the first quadrant, and in the first quadrant all are positive. So cos B will be positive, you will consider only plus sign. So under root of 1 minus sine square B. So according to the quadrant of the angle, we consider the sign of cos or sine. So plus under root of 1 minus sine B value is here 4 upon 5. 4 upon 5 square. 4 upon 5 square is equal to under root plus under root of 1 minus 16 upon 25, which is equal to under root 25 minus 16, on taking the LCM, 9 upon 25, and 9 upon 25 is equal to 3 upon 5. So we have got the values of cos A and cos B. Cos A is minus 5 upon 13 and cos B is equal to 3 upon 5. So we need to put this value here. We get sin A plus B is equal to sin A. The value of sin A. Value of sin A is 12 upon 13. Sin A is 12 upon 13 into cos B. Value of cos B is, we have calculated 3 upon 5, plus cos A. Value of cos A we have calculated minus 5 upon 13 into value of sin B. Sin B is given in the question, it is 4 upon 5. So into 4 upon 5. Now this is equal to 36 upon 65 minus 20 upon 65, which is equal to 36 minus 20 is 16. 16 upon 65. So we have got the value of sum of angle A plus B, sine of A, sum of A plus B, sum of A and B. Now we need to calculate here cos of A plus B. Cos of A plus B is equal to, you know the formula, cos of A plus B is equal to, in cos we have the opposite sign, so cos A cos B minus sin A sin B. Now put the values here. Cos A is minus 5 upon 13. Cos B, value of cos B is 3 upon 5 minus sin A. Value of sin A you can see here 12 upon 13, and the value of sin B is 4 upon 5. So this is equal to minus, further simplification, minus 5 into 3 is equal to minus 15 upon 65, and 12 into 4 is minus 48 upon 65, and on adding for minus 48 and minus 15, this is equal to minus 63 upon 65. So the students, for the value sin A plus B, value is 16 upon 65, and the value of cos A plus B is equal to minus 63 upon 65. I think the students, you have understood the method how to evaluate the values of the sum of sine or cos uh, using the quadrant concept. Now with this question I conclude today's session. Like and subscribe my channel for new videos, and for more questions see the next part of trigonometry.